All right. Hello, friends. Hi, everyone. Welcome back to the Gyres Trash Academy, where we learn all about the life cycle of plastic. Once again, my name is Melissa Awayo, and I'm the program director at Gyres. Really excited to be here with you all today. A little bit of a harder subject. So last time, we followed our plastic friends along a grand adventure, following ocean currents, learning about the 5 main subtropical gyres. We also learned how plastic breaks down in our oceans into smaller and smaller pieces called microplastics, creating that plastic smog. But the journey for plastics doesn't end here. Plastic does not belong in our waterways and oceans, and when it ends up there, it can cause some pretty serious problems. We have come a long way on our journey. We followed plastics from when they were invented to how we use them, followed them along to their paths to landfills and recycling centers, through watersheds and into rivers. We followed them across whole oceans and through currents and gyres. And as we near the end of our journey, we have come to one of the most important topics regarding plastic pollution: its impacts. We are going to take a deep dive into the harmful impacts of plastic pollution on wildlife and on us. We're going to try to start to understand why plastic pollution is bad for everyone, so that we can really become empowered to find solutions and take action. So have you heard of the word tangled before? Plastic in our oceans, especially plastic items such as fishing lines, fish nets, plastic bags, and plastic packaging, make it really easy for animals living in the ocean to get caught or entangled. We're going to see what it might feel like for an animal like a turtle, a sea lion, dolphin, whale, or a fish that becomes entangled in a piece of plastic. So we're going to do a little activity. If you have a rubber band at home or a hair tie, go ahead and grab one and follow along. So really easy. It's a trick I used to like to do in my classroom presentations as well. So you put a rubber band or a hair tie around your thumb and your pinky finger. And you imagine that you are a marine animal that accidentally got trapped in this plastic band. I see some of these images and I honestly don't know how it happens sometimes, but it happens all the time. Okay, so what I used to do is I used to pick a group of 10 students, bring them up, give them a rubber band, and give them 20 seconds to try to get this off. You kind of struggle and you're really trying and you're really tempted to like use your mouth or use your other hand, and it is really, really challenging. So imagine if you have this rubber band on all the time and you have to continue on with your life. You have to eat, you go to school, you work, you shower, you sleep with it on. It's probably going to become very irritating. We are really lucky as humans because we have opposable thumbs. So if we get stuck in something, if we get entangled in something, we could remove it pretty easily. Marine animals aren't so lucky and often become entangled in plastic debris and cannot escape. Just think how this might feel for some of those marine animals. Is it dangerous? Could it cause them harm? As you saw, my hand was caught and trapped in this rubber band, which is very similar to the turtle on the left that got stuck in a 6-pack ring. This is a great example of a poor design. We've been telling people to cut their 6-pack rings at home for this very reason. But people have also spoken out, and we are seeing these 6-pack rings being phased out, which is amazing. We'll discuss more about design flaws and innovation and solutions on next week's lesson. You'll also notice that in both slides, you saw images of a seal and a penguin caught in a net, a ghost net. So ghost nets are pretty scary. They're fishing nets that have been left or lost in the ocean by fishermen. These nets, often nearly invisible in the dim light, can be left tangled on a rocky reef or drifting in the open sea. Other ghost nets might get caught in it, and unfortunately, a lot of animals can become trapped or entangled in them, resulting in catastrophic harm. Okay, so we know that animals can become entangled in plastic debris in our oceans. How else can plastic harm marine animals? They can eat it. When marine animals consume plastic, this is called ingestion. As plastic is ingested, it works its way up through the food chain. What's a food chain? Well, a food chain is the relationship between predators and prey in the wild. The food chain begins with plants or producers. These organisms create their own food through photosynthesis. They get their energy from the sun and the water. These plants are then eaten by smaller animals that cannot produce their own food. These animals are consumers because they have to eat to get their energy. And then those animals are eaten by larger animals, and so on and so on. In the ocean, the food chain begins with small plant-like organisms known as plankton. Some plankton are producers and can produce their own food like plants, phytoplankton, and these are eaten by other plankton that are consumers and need to eat their food. So those plankton are eaten by fish, and those fish are eaten by larger and larger predators. You get the idea. So plastic pollution, small and large, can be consumed by marine animals. Why do you think eating plastic would be bad for a marine animal? Let's take a look at this brief clip to learn more about how plastic ends up working its way up through the food chain.
These tiny pieces of plastic that are floating on the surface of the ocean come from larger pieces. Over time, the sun's ultraviolet light, ocean wave action, and salt break it up into smaller pieces called microplastics. Microplastics have rough, pitted surfaces. Waterborne chemicals from industry and agriculture stick to microplastics, making them toxic poison pills.
So what this means is the feeding that's occurring on the surface of the ocean has these plastic fragments floating around and is actually intermixing in the food chain.
When animals eat plastic, they're also consuming the toxins attached to the plastic. Toxins pass into the bloodstream. There, they bioaccumulate in the fatty tissue and around the vital organs. When animals use the stored fat, the toxins circulate around the body, interfering with reproduction, metabolism, growth, kidney, and liver function.
That's the part we like to eat, and that's where these chemicals migrate to.
You expect that you're finding derivatives from plastics in the blubber of these animals because they're consuming other animals that are directly consuming the plastics.
Exactly.
And so if the plastics are in the food chain for the dolphin, they're also in our food chain.
Exactly.
All right. So as predators eat prey that are contaminated with toxins from plastic, these toxins begin to accumulate. We call this bioaccumulation or biomagnification. Bioaccumulation refers to the concentration of pollutants in an organism, whereas biomagnification refers to an increase in the concentration in a food chain. So bioaccumulation within the organism as it accumulates, as it gets older and is eating more and more, whereas biomagnification is happening on the food chain level. So that would include us at the top of that food chain. So plastic that has absorbed chemicals can enter the food chain at the very beginning and cause harm. In fact, we're already starting to find plastics and toxins in our seafood because of this. What about the thing we mentioned where plastic absorbs toxins, this idea of this toxic sponge? To answer that question, we need to take a closer look at plastic and its special abilities. We've learned so much on our plastic journey so far. When we first began, we learned all about what plastic is and how it is made. Plastic is a very unique man-made material, and like other materials, it can do things that other materials can't. Scientists have recently discovered that plastic can act as a sponge and has unique properties that will absorb many forms of toxic materials as it ages during its lifespan. It can also adsorb, meaning it can also release those toxins. So just like you can squeeze a sponge and it can squeeze out all that water, plastic can do the same. So in the ocean, plastic absorbs toxic chemicals like PCBs, DDTs, pesticides, and flame retardants, things that are used in our clothing, in our lawns. Chemicals linked to endocrine, and these chemicals are linked to endocrine disruption and even cancer. So some of those things that you heard about the animals, how it's impacting liver and endocrine disruptors and all of that is also something that's of concern to humans. So a tiny piece of microplastic can be 1 million times more toxic than the ocean water around it. And as it degrades, these plastic pieces can also release those toxic chemicals. So that's where you're seeing that adsorption. And these toxic plastics can work their way up the food chain and onto our plates, because we're at the top of that food chain, right? So take a look at George here. If you watch Junkcraft, you might recognize him. He is a fish that our co-founder, Marcus Erickson, caught in the middle of the North Pacific Gyre. So when he was out there doing that journey, they're running out of food. They caught this fish for sustenance, and they found 17 pieces of plastic in George's belly. He is no exception. He's one of 1,200 species who are being impacted by plastic. It's estimated that 70% of fish and 33% of shellfish have ingested plastic. Marine birds are especially impacted, with 90 to 99% having plastic in their guts. This is a Malaysian albatross out in the middle of the Pacific. And again, people like to study these albatross because you can learn a lot by what they're consuming and how that is changing. So what could this mean for you and I? How much plastic is ending up on our plates? A recent study suggested that we are eating, swallowing, or breathing. Remember, these microplastics break up super, super teeny tiny. About 2,000 tiny particles of plastic, or the equivalent of 1 credit card, every single week. While we're still studying how exactly these pollutants can move up the food chain, we know enough to know that eating a credit card worth of plastic can't possibly be good for us. So, plastic is obviously an animal rights issue. It's an environmental issue, but it's also an environmental justice issue. Plastic pollution is a human rights and cultural issue as well. In 2015, a study published in Science determined that 8 million metric tons entered our ocean in 2010, enough to cover every foot of coastline in the world. Most of the plastic came from heavily polluted countries with poor waste management systems, such as China, Vietnam, Philippines, and Indonesia. What the report did not cover, however, and what it failed to acknowledge, very, very important, is that many developed countries, like the United States, export their plastic waste. In 2011, China imported nearly half of America's plastic waste. And when that country began restricting these imports, we saw plastic exports from the US to Indonesia increase by 219%. In many of these countries, people, including children, have become waste pickers, sorting through rivers of plastic trash to find pieces to sell, while polluted waterways transport the remainder out to sea. Many of these countries rely heavily on seafood as their primary source of protein. If we don't make changes now, by the year 2050, plastic production will triple, and the amount of plastic in the ocean will outweigh fish. What does that mean for communities around the world? What can we do to be a part of the solution? Right? That's why we're all here today. So now that we know more about the perils of plastic and how it impacts our oceans, marine life, and even the food we consume, I want to challenge you to replace 2 items in your grocery cart or your online grocery order with non-plastic packaging options the next time that you happen to be in the store or you happen to be placing an order. Again, totally acknowledging that things are a little more challenging right now, but even small personal choices like this can make a huge impact if we all take these steps together. And it's only one part of the solution though, right? So be sure to join us next week as we discuss more opportunities on solutions. Essentially, learn how you can truly make a huge impact in taking steps to reduce plastic pollution and help solve this global environmental crisis, because there is a way to solve this. Thank you so much for tuning in, and be sure to join us this Thursday, tomorrow, for our second episode of La Academia de Basura, or our Spanish version, or tune in next week where we're going to talk about solutions. All right, y'all. Hope you have an amazing rest of your day.